Hi, welcome to another great video shorts on limits. This is my example 8 and I've chosen a very interesting limit for us to work on today. This is a limit that you will very rarely see evaluated. I remember as a young student not being able to determine a technique for solving this limit without going to the library and doing some research. But before we attack this little beastie, you remember the first thing you should always do is look at the value that x goes to, in this example here, 0, and substitute that value into the expression. So let's make that substitution. We'll do some house cleaning, and we obtain 0 over 0. Now this is an indeterminate answer, and that is just a very polite way of saying that algebra will be our best friend, and it will certainly assist us in resolving this limit. Now remember, there are other types of indeterminate forms for algebra to assist you with, and that is if you ever obtain the value 0 over 0, 0 times infinity, or infinity divided by infinity, or infinity minus infinity, 0 to 0, infinity to 0, or even 1 to the infinity, then these indeterminate forms will require a algebraic process to help you resolve the limit. So let's go back to our beastie here. Now, the first thing you should always do to look for a hint at what will cancel out that 0 over 0 is look at the expression that x goes to. In this case, x goes to 0. And therefore, if we can cancel out an x, we are canceling out the 0. So hopefully, we should obtain an x in the numerator and an x in the denominator, and these two x's will cancel out, and thus removing the indeterminate form. The problem is that numerator, because if you look carefully, you see you have the cube root of x plus 1 minus the cube root of 1 minus x. And you're looking at this and saying, where do I go from here? You cannot multiply by the conjugate, because the conjugate will only work with square roots. It actually makes it even worse with cube roots. Now this is where you look for hints. Now it would be a lot nicer if we wrote the expression this way. So I wrote the cube root as an exponent of 1/3, and it almost looks like a difference of cubes, except it's not a cube. It's a cube root. But anyways, because it looks like a difference of cubes, this is a hint for you. So let's just recall our technique in dealing with a difference of cubes. So if it was a difference of cubes, we actually have a recipe for resolving this. Now the recipe is kind of neat. It says if you've got, let's say, a cubed minus b cubed, you can factor that into a minus b times a squared plus ab plus b squared. Now it doesn't have to be a's and b's. It in fact could be any symbols. It could be cows or horses, or in my example here, right side up triangles minus upside down triangles. But you see the pattern. It's something cubed minus something cubed equals something minus the other something times something squared times something times the other something times the other something squared. Or maybe I'll use a to the 1/3 cubed minus b to the 1/3 cubed. Well, that would equal a to the 1/3 minus b to the 1/3 times a to the 1/3 squared plus a to the 1/3 times b to the 1/3 plus b to the 1/3 squared. Or even this as x plus 1 to the 1/3 cubed minus 1 minus x to the 1/3 cubed. Now look carefully at this. Look at this term here. That is in fact the numerator of our expression. This is telling us that if we multiply this term by this value, and that is the product of these two beasties, they will actually simplify to this. is the clue that we're going to look for. We're going to multiply our numerator by the orange box, and we will get the answer in the purple box. Now, at first glance, you may be saying, well, why do I want to do something to make it look uglier initially? But if you look at the purple box, I've got x plus 1 to the 1/3 to the power of 3. Well, 1/3 times 3 is 3 over 3, and the exponents will cancel out. And if the exponents cancel out, that gives us a very simple expression from our numerator. So let's give it some working room, and we'll watch that work. So here's our expression. I'm going to multiply the numerator by the stuff in the orange box, but remember, I also have to multiply the denominator by the same stuff, because I can only multiply by equivalent of 1. Because we're multiplying the blue box times the orange box in the numerator, we get the purple box. And the purple box looks a lot nicer, but look at that 1/3 and look at the power 3. I'll do some house cleaning, and look what our numerator simplifies to. That ugly cube root disappears from the numerator. Let's give it some more working room and do some house cleaning. So I've got x plus 1 minus bracket 1 minus x. Be careful about subtracting stuff in brackets, so let's very carefully write that out this way. So it's minus 1 minus x, so it turns out to plus x. Let's do some house cleaning. Do you see it? In the numerator, I have an x. In the denominator, I have an x. We can say hasta la vista to the x's. Simplify. We now can substitute our 0 in for x, because we've just canceled out the 0 over 0. Do some house cleaning. More house cleaning. And finally, we obtain the answer of 2/3. So this is a very interesting technique in solving a very interesting limit. I would go over this a couple of times to recognize the pattern, because it's a useful tool in solving cube roots plus or minus cube roots. Thank you.